Hi all, welcome to the video lecturing series of data mining and warehousing. In this video, we will discuss about clustering analysis. So, before going into detail about clusters and analysis of cluster, I will be discussing a few things regarding supervised and unsupervised learning, classification, all these concepts. So, we already discussed about the supervised learning concept in our class. So, a supervised learning method means in that learning a supervisor is present as a teacher. That means here we teach or train the machine using the data which is well labeled. That is, a supervised learning algorithm analyze the training data and produce correct outcome from the labeled data. Now, what about the unsupervised learning? In case of unsupervised learning, it is training a machine using the information that is neither classified or nor labeled. That is, supervised learning algorithm act on that information which is not having any guidance. Like in supervised learning, a supervision is there, like that nothing is there in the case of unsupervised learning. Here, the task of machine is to group unlabeled data, or we have to sort the information according to the similarities and pattern present. So, how we will be doing the unsupervised and supervised learning? In case of an unsupervised learning, there will be hidden structure from the labeled data. This like we'll extract or we'll find some hidden structure from the unlabeled data. I'll tell you one example is like if you are given with some set of images like cat and dog, and if you are asked to classify, classify that those images, we cannot classify it based on some particular label because it is not associated with any label or not. But by using the pattern or similarities of the image, we can classify it into two groups, like one is cat image, one is dog image. So like that you can do. So unsupervised learning will be handling only unlabeled data, and here it is explore the data to find the intrinsic structures among the unlabeled data. Now, what about the classification and clustering? What is the main difference between classification and clustering? In case of classification, it learns a method for predicting the instance of classes from the pre-labeled instance. It is like it is working on a pre-label or labeled data. Now, in case that is a supervised learning approach, and unsupervised learning means we will not be having a label or any. So it is like will not be having neither class or nor labels. Now, clustering is an unsupervised learning method. Clustering finds a natural grouping of instance from a given unlabeled data. Now we will move on to the clustering. What is the definition for clustering? Clustering is the process of grouping objects of similar items together. So a cluster should be clusters of an object contain objects of similar kind only. Like a cluster of data object can be treated as a one group, and here while doing the cluster analysis, we first partition the set of data into groups based on the data similarity and then assign the label to that group. Here one thing you have to notice is like while clustering, intra-cluster similarity will be high and the inter-cluster similarity is low. That means inside a cluster, all the objects inside the cluster should be very much similar, and the clusters from one to another, there are two clusters and the objects inside each cluster should be different. Then only we can tell it is properly classified or it is properly grouped. So, a cluster is nothing but a process of grouping similar objects together. So, that cluster can be considered as a group. Now, we have to discuss what are the main requirements of clustering. while doing the clustering analysis, the typical requirements for clustering analysis are scalability and ability to deal with different kinds of data, discovery of clusters with arbitrary shape, high dimensionality, and ability to deal with noisy data. These are the main requirements. I will see the first one, that is scalability. What is meant by scalability? The clustering algorithm will work well with the small set data set as well as with the large data set. Sometimes this clustering process will work very good in case of small data set, and with the largest data set it may produce biased result. So the clustering algorithm should be always scalable. It should work well with large and small data set. Now what about ability to deal with different kind of attributes? Algorithm should be capable to be applied on any kind of data, such as data may be of different type, like it may be binary, categorical, ordinal, or any such kind of data. The clustering algorithm should be capable to handle all these things, all this type of data. That is the second requirement. Now the third is discovery of clusters with arbitrary shape. The clustering algorithm will be capable of detecting the clusters of arbitrary shape. They should not be bounded to only a distance measure or tend to find any spherical clusters of small size. It should not be like that. It is like the clustering algorithm work well with arbitrary shape means normally we will be using the spherical shape, but it should be capable to classify other shapes also. Now high dimensionality is the next requirement. It is like the clustering algorithm will be capable, should not only be able to handle low dimensional data, but also to handle high dimensional data. Next is the clustering algorithm will be able to handle the noisy data. Sometimes the database may contain noisy, missing, or any erroneous data and all, and some set of algorithms, some set of clustering algorithm may be very much sensitive to these errors and all, but for a good clustering algorithm, it should be able to handle all the noisy data or erroneous or missing data and all. Then next is like it should be interpretable. The clustering result should be interpretable. That is another requirements for clustering. So these are the main requirements for clustering. Next we are going to discuss about the types of data in cluster analysis. So we already discussed the clustering algorithm will be able to handle all kinds of data present in the database. So which are the kind of data that we are going to come across? So these are the some type of data. First one is binary variable or binary data. So we are very much familiar about this. It is like here in case of binary variable, there will be only two states, either 0 or 1 will be there, that is present or absent. In order to show the presence of some particular thing, or in order to show the presence, or in order to show the absence, we are using this. Here in case of binary variables may be of type symmetric and asymmetric will be there. In case of symmetric binary variable, it is like binary variable is symmetric if both of its states are equally valuable and carry the same weight. That is the case of symmetric binary variable. But in the case of asymmetric binary variable, here binary variable, the states are not equally important, such as some examples I will tell you. In case of symmetric binary variable, it is like both the states, either 0 or 1, both the states are having equal weight. So one example is like one attribute called a gender. In case of gender, two sets of values are there, two states are there, like either male or female, and these two states are having equal weightage. That is the case of symmetric binary variable. Now in the case of asymmetric binary variable, it is like the outcome of the states are not equally important. Here the example is like for a test, like if we are doing some particular test, for that particular test, positive value will be there, negative value will be there. Sometimes we are considering only positive value. So here there is no equal weightage for both positive and negative. In the case of Quran and all, we will consider only positive cases, right? Similarly, in asymmetric binary variable, both the states are not equally important. It is considering only some particular state is important. But in the case of symmetric binary variable, both the states are equally both the states has equal weightage. So next is categorical variable. Here in the categorical variable, it is the generalization of a binary variable. It can take more than two states. For example, you can see a map color for for coloring the map and all. I'll be using some set of colors like red, yellow, green, pink and blue and all. These are all colors like for coloring that map we are using the set of colors. So it can take a more values. So here it is like next point is to notice is dissimilarity between objects. Similarity is defined by d of ij is equal to p minus m by p. Here p is the here p means p is the total number of variables present, and m is the number of matches. Here we have to find the dissimilarity, how it is dissimilar with another object. In order to find the dissimilarity, we are using this equation p minus m by p. Here p is the total number of variables and m is the total number of matches. So that's all about the categorical variable. Next is ordinal variables. In case of ordinal variables, a discrete ordinal variable resembles the categorical variable except that m of the ordinal value are ordered in a meaningful sequence. It is like ordinal values are ordered in a particular sequence. One example I'll tell you. And it's like in the case of ordinal values, if we are ranking professional ranking of teachers, it is like professor will be there, then associate will be there, then assistant will be there, like that. Professor, associate professor, assistant professor. So these are the professional ranking. Here this sequence, there is a sequential order for that. Now it may be the ordinal variables may be discrete or continuous. In case of continuous value, I'll tell you one example. It's like in continuous value, for a particular sports and all, if we are giving some gold medal, silver, bronze, for all this like it is showing first, second and third position. So it is like a continuous order is there. In order to show that, we are using continuous ordinal variable. Next is ratio scaled variable. Ratio scaled variable make a positive measurement on a non-linear scale, like it is we are using an exponential scale and all. In that we are using the formula ae raised to bt or ae raised to minus bt. These are the two equations. Here a and b are the positive constant and t is representation of the time. So ae raised to bt is the exponential formula and a and b are the positive constants here, and t is representing the time. Next is mixed type. In case of mixed type, data may be either, it may be of any type. It may be of either interval scale or symmetric binary, categorical, ordinal or ratio scaled. It may be of any type, and the dissimilarity found separately for each variable. Here separate variables will be there for classifying or in order to find the dissimilarity. If a data contain interval scaled and symmetric and all, we will be finding the dissimilarity of each object separately. So next is vector object. Vector object you have to study is like vector objects x of x, y, similarity between two objects, two vectors x, and similarity between two vectors x and y is given as s of x y is equal to x dash y divided by mod x into mod y. Here x dash is the transposition of vector x. Transposition of, here we are considering the two vectors x and y, and the transposition of x is x dash, and Euclidean norm of x is given as norm x and norm y. So that's all about the types of data. Now here each data are there, and while finding the similarity between the objects or how it is differ from another cluster, we have to find the dissimilarity. In order to find the dissimilarity, we are using some set of distances for that. Distance measured used for measuring the dissimilarity are Euclidean, Manhattan and Minkowski distance. So Euclidean distance we already discussed. D of ij is equal to xi1 minus xj1 whole square plus xi2 minus xj2 whole square plus etc. xin minus xjn whole square. This is the equation for Euclidean distance. So this distance here, I is equal to, I may be xi1 comma xi2 etc. xin, and j is yi1 and yi2 like that, and n is the here n dimensional x, I and j are the n dimensional data vectors. Next is Manhattan distance. Here in Manhattan distance you will be you are using the equation d of I is equal to xi1 xj1 plus mod xi2 plus minus xj2 plus etc. up to xin minus xjn. Here the distance, both the distance measures satisfy this Euclidean and Manhattan distance. Both the distance satisfy one equation is like d of ij value. Here d of ij is greater than or equal to 0 means the distance is non-negative. Here it is equal to 0 means the distance of the object itself is 0. D of ij is equal to 0 means d of ij is equal to d of ji. If it is like that, d of ij is equal to d of ji, distance is a symmetric function. So once again I will repeat. So this both Euclidean and Manhattan distance satisfy some set of requirements, like if d of ij greater than or equal to 0 means it is a non-negative distance. If it is equal to 0, distance to that object itself is 0. If d of ij is equal to d of ji means it is symmetric. And one more is there, triangular inequality of the distance, that is d of ij, less than or is equal to d of I comma h plus d of h comma j. That is known as triangular inequality of the distance. Ij is less than or equal to d of ih plus d of hi. Next is Minkowski distance. This is the generalization of both Euclidean and Manhattan distance. It is founded by the equation d of ij is equal to xi1 minus xj1 whole raised to p plus xi2 minus xj2 whole raised to p etc. up to xin minus xjn whole raised to p whole raised to 1 by p. So here p is the positive integer, such as distance also positive integer, and LP distance is also called the LP norm. Here the Minkowski distance is also known as LP norm and all. That's all about the distance measures of dissimilarity. These three you have to study these three equations. Sometimes question may ask by giving some distance, like x is equal to some set of values. X is given as some values like 2, 3 and y is given as some 3, 5 and find Euclidean distance or Manhattan distance, like that questions may ask. So you have to study this equation thoroughly. So that's all about distance for finding the dissimilarity. Next is what are the main applications of clusters. Here the main applications like the clustering analysis is used in wide variety of application. One is like it is used for market research, pattern recognition, data analysis, image processing and all. So in case of market research, for a customer, for a retailer or a corporate businessman, while doing the business he may be knowing some set of age group what set of items are buying. So by clustering that, he'll be getting a clear idea or clear pattern about the market trend. Next is for pattern recognition and image processing and all, we are using this cluster analysis, and is used in biology. It's like to derive the plant and animal taxonomies, like plant and animal kingdom is there, it is classified as vertebrates, mammals and all. So in order to classify that, so this classification is done through the similarities of behavior and their behavior and their genetical and other behavioral patterns and all. So it is used in biology also. Next is used in geography to identify the areas, similar areas of land for earth observation and all, we are using this. Next, to classify the document on the web for information recovery and used for outlier detection and all. It's like if we are using some credit card fraud detection and all, we are using this clustering for outlier detection purpose and all. So that's all about the clustering and the basics of cluster analysis and application of clustering. Thank you.